In this video, we will learn about elements. In 1661, Robert Boyle gave the first scientific definition of an element, and with slight modification, this definition is still in use. He stated that there are substances that can be thought of being of ultimate simplicity and cannot be broken down into yet simpler substance. Antoine Lavoisier in 1789 stated that an element is the basic form of matter and cannot be broken down into simpler substances. He also gave the first modern list of chemical elements, which has 30 elements. Elements during that time were distinguished by their atomic weight, but in nowadays we use atomic number to distinguish different elements. So here we have the modern definition of element. We can define element as follows. Element is a pure substance that cannot be broken down into any simpler chemical substances by physical or ordinary chemical means and is made of atoms of same type. In other words, we can say that an element is a type of matter composed of atoms that have all the same positive charge on nucleus, that is, they have same atomic number. And these elements are divided into three classes. First is metals, second is non-metals, and third is metalloids. Let's understand about metals. Some important characteristic properties of metals are as follows. First is metals are solid at room temperature. Exception is mercury, which is liquid at room temperature. Gallium and cesium become liquid at temperature slightly above the room temperature. That is, melting point of gallium is 303 Kelvin or 30 degrees Celsius, while that of cesium is 302 Kelvin or 29 degrees Celsius. Next is metals have lustrous surface. Lustre means shine. So lustrous surface means that metals have shining surface. They generally have silver gray or yellow color. Next is metals are generally hard. Exception to this is metals like sodium and potassium, which are soft and can be easily cut with a knife. Next property that we have is malleability. Metals are malleable, that is, they can be hammered into thin sheets. Gold is the most malleable metal. Thin sheets of silver are used for decorating sweets, whereas thin sheets of aluminium, that is aluminium foil, are used for wrapping food items, medicines, cigarettes. Copper and aluminium are also malleable and are used for making utensils. Next property is that metals are ductile. Ductility is the ability to be drawn into thin wires. Platinum is the most ductile metal, whereas silver and gold are also highly ductile and are used for making ornaments. Copper is also very ductile and is used for making wires. Aluminium wire is used in electric transmission lines. Next property is metals have high melting and boiling point. Exceptions are mercury, gallium, cesium, and potassium. These are the metals that have low melting points. Next property of metal is metals are good conductors of heat and electricity. Silver is the best conductor of electricity, followed by copper and aluminium. Exception to this is lead and mercury. They are poor conductors of electricity. Next property is sonority. Metals are sonorous, that is, they make ringing sound when struck, and hence they are used in manufacturing of bells. Out of 92 elements that occur in nature, 70 elements are metals. Here we have some common examples of metals: sodium, potassium, silver, gold, mercury, aluminium, copper, calcium, magnesium, and iron. Aluminium is the most abundant metal in Earth's crust, followed by iron and calcium in the decreasing order of abundance. Now let's understand about nonmetals. A chemical element which mostly lack the characteristic property of metal is called nonmetal. The important characteristic properties of nonmetals are: first, nonmetal are either solid, liquid, or gas at room temperature. For example, carbon, sulfur, and phosphorus are solid, bromine is liquid, and oxygen, hydrogen, nitrogen are gaseous nonmetals. Next property is nonmetals are non-lustrous. Exception is iodine, which is gray-violet solid at room temperature and has luster or shine. Next property is nonmetals are generally soft. Diamond, which is allotropic form of carbon, is the hardest known substance on earth, and this is an exception. The next property is that nonmetals are non-malleable and non-ductile, which means they cannot be beaten into thin sheets or drawn into thin wires. Solid nonmetals are generally brittle and they break into pieces when hammered. Examples are sulfur, carbon, iodine, phosphorus. Next is nonmetals have low melting and boiling point. An exception to this is graphite and diamond, which are allotropes of carbon and have high melting point. Next is nonmetals are poor conductors or insulator of electricity. Exception to this is graphite, which is a very good conductor of electricity. Next is nonmetals generally have low density and nonmetals are also non-sonorous. That means they do not produce ringing sound when struck. Here we have some common examples of nonmetals. There are about 15 elements which are nonmetals. Examples are carbon, sulfur, phosphorus, oxygen, nitrogen, chlorine, bromine, and iodine. Here we have one example each of a metal and a non-metal. Gold is a metal whereas bromine is a non-metal. Here we can observe that the pieces of gold are shining, which means they are lustrous, and luster is the property of a metal, whereas bromine is liquid and is non-lustrous, which is a property of a non-metal. Next we have metalloids. Some elements show some properties of metals as well as of non-metals, and such elements are called metalloids or semi-metals. Examples of such elements are boron, silicon, germanium, arsenic, and antimony. Metalloids are those elements which show some of the properties of metal and some properties of non-metal, hence they are grouped in a different category which is called as metalloids. I hope this topic is clear to you. Thank you.